This film's going to be about the chemistry in 21st century science and how we came to choose the particular content, contexts and themes. And it's worth making the point that it wasn't just the team members, myself, John Holman and others who did this, but we consulted chemists, science writers, a wide range of people, teachers, to try and decide what would be an appropriate way of presenting chemistry in the course. The first big idea we wanted to get across was a real understanding of what's going on in a chemical reaction. And that's where we chose air quality, because we felt that if people understood a chemical reaction well enough to know why burning a fuel in a motor car can contribute to air pollution, that was an important aspect of understanding. The second theme comes up in C2, the materials module, where we're living in an age of emerging nanotechnology. Scientists can do extraordinary things with atoms and molecules. And staying with molecules, we use polymers to try and understand how scientists can do that. And then thirdly, there's a lot of prejudice in society about the very word chemical. So in the context of food, in C3, we explore what we mean by a chemical, what we mean by natural and synthetic chemicals. Turning now to the ideas about science, I think there are two big contributions of the chemistry. In both C1, air quality, and C2, on materials, measurement. How do scientists make accurate measurements, validate those measurements, and how do you interpret and make sense of those measurements? And then secondly, sustainability. There's a lot of waffle about sustainability. What does it really mean, and what can science contribute to our understanding of it? And particularly in the materials module, we take, using life cycle assessment, we take a really rather rigorous look at what sustainability might mean in the context of chemistry. Now, in additional science, we really want to show young people what it's like to think as a chemist and look at the world through the eyes of a chemist. The first module, C4, is about atomic structure in the periodic table. And as chemistry teachers, I think we sometimes lose sight of the fact that we're trying to teach a most extraordinary idea, the idea that a really quite simple model of atomic structure can account for the periodic table and rationalize the properties of large numbers of elements and compounds. And we want to celebrate that, and at the same time, we want to show our students some really exciting chemical reactions, things they'll only see in a chemistry laboratory. So we want to put sodium on water and react iron with chlorine and do some really quite exotic things, which is fun. Then in the second module, C5, which is about chemicals in the natural environment, traditional chemical ideas, structure and bonding, but presented in the context of the environment.
It's brought it alive, and it's really brought alive the natural world to them, to help them look at the environment and see, okay, this is the air, and this is what's going on in the bonding with your particles and these gases. You look at a piece of metal, and you know that there's different types of bonding going on. There's metallic bonding. You look at something else, and you know other types of bonding, which I think has been really, really important in chemistry to contextualize the understanding, the theory, to the natural environment, which I think, for me, is the most inspiring part of science, and it's the natural world and what's going on with it, how does it work, what's going on at the atomic level, molecular level, how does it all work, and that's C5.
The last module, C6, deals with the uses of acids and alkalis to make particularly salts, but other new chemicals too. And this module also brings out and concludes a very important theme of additional science. We've introduced ions for the first time in C4. We've then looked at ionic giant structures in C5, and then finally in C6 we show how an understanding of ions can explain the reactions of acids and alkalis and the way they're used in chemical synthesis. In C7, we set out to do three things. We wanted to teach them more chemistry. That includes some carbon chemistry, organic chemistry, energetics, and reversible reactions. The second thing is to introduce some of the skills of analytical chemistry, in particular titrations and chromatography, building on the themes that they've met before in both science and additional science, but also showing what ideas about science mean in a chemical context. And then the third aim is to emphasize, yet again, some of the applications of chemistry. One of the big developments in modern chemistry is green chemistry, and of course that picks up on the GCSE science theme of sustainability and extends it in a more sophisticated way for those people who are particularly interested in chemistry.